Hello, welcome everyone to this Small Cells World Summit webinar on Small Cell Open RAN. Next year, we'll be hosting a series of online webinars and a virtual conference in May. Small Cells World Summit as a live face-to-face event will take place in May 2022 in London. I'm delighted to welcome representatives from Small Cell Forum, Qualcomm, Radisys, Reliance Jio and Picocom for this webinar. And I'd like to hand over now to Julius Robson, Chief Strategy Officer of the Small Cell Forum, who'll be hosting this session today.
Right, thank you, Claire. Hello, everyone. I'm Julius Robson, Chief Strategy Officer of the Small Cell Forum. And today I'm going to be giving you a short introduction to the Small Cell Open RAN specifications, which are FAPI and Open Option 6. And then we'll have some presentations from some of the companies who are implementing those, talking about the applications of those. So, first of all, let's look at Open RAN. Open RAN promises many things. And broadly, it's about interchangeability of parts and interoperability of interfaces. And the idea here is by being open with our specifications, we encourage the multi-vendor interoperability such that people integrating components into boxes can mix and match their component supply chain. People providing components can generate economies of scale by being able to offer to a large market. You reduce the custom engineering if all the components are interchangeable, and it also reduces barriers to entry to new players. So the interoperability aspects can bring these benefits if done right. The other part of Open RAN, of course, is the disaggregation part, which means both the disaggregation of the traditional base station into radio and distributed unit parts, which can have coordination benefits and pooling gains. But there's also the disaggregation of network functions from the underlying hardware. And this is the path to virtualization, which takes you then to cloudification, enabling automation orchestration, which is better for scalability up and down, and service agility with DevOps. So lots of promises. And it's really good to see that the various Open RAN standard setting groups are not only just creating these standards, but they're also driving through on these promises as well. So if we look specifically at small cell Open RAN, essentially there are two parts to it. There's the FAPI and there's Open Option 6. FAPI is an open API for components used in small cell base stations. And for this we have three flavors. There's a PHY FAPI, this is the main one, but there's now for 5G an RF FAPI and a SON FAPI. And these essentially represent the API that chipset manufacturers work to, which mean that integrators can write software to support those components. On the Open Option 6 side, this is a split Option 6 front haul interface between disaggregated parts of the base station, the SDU and the S-RU. So that's the two flavors. And just we look at the applications of these two Open RAN standards. So on the one hand, we can look at a 3GPP base station, which is a Geno B or even the Geno BDU part. And the FAPI is applicable to that unit. So you can have the PHY FAPI in there. A system on a chip, PHY physical layer can sit inside that box. So can the RF front end part and also the SON FAPI, which is a network monitor mode. So we specify the API for those, and chipset manufacturers make chips for those. So people making Geno Bs can benefit from that and mix and match the chipset and the software stack. The Option 6 interface is actually an interface between an SDU and an S-RU. Now, Option 6 is also known as Network FAPI, and in fact, what it does is it takes these API and transports them over a network connection between an RU and a DU. It's a very efficient implementation of these API. And finally, the PHY FAPI is also applicable in the ORAN ODU, where the high-PHY component can interface to the software stack. So just to point out really that the FAPI standards are applicable to a broad range of 3GPP Geno Bs, also Forum S-RUs and ORAN ODUs. And this is the full family of specifications for FAPI. So you'll see that the FAPI specs, there's quite a few of them, and they go back to 2G and 3G and 4G, as well as the new 5G specs. For 5G, we've seen an expansion of the scope of FAPI, to encompass not just the basic FAPI API, but also the RF front end, and the network monitor mode, as it's called, as well as the option 6 network FAPI and associated management models. There's quite a range of specifications there. All these are freely available, and you can download them from our website, smallcellforum.org there. And these numbers represent the specification names. And if you do want to know more about these specifications, I do encourage you to go to our website, where we have not only the specifications, but some quite useful information, some videos by the people who wrote the specs, talking about how they're set out, how they work, and how they can be used. So we have those for all the FAPI suite there for 5G, but also for the network FAPI Open Option 6 specification. So today's webinar, we're going to hear from a number of companies on the different applications for these specifications and how those companies see them being used in the real world. First up, we're going to hear from Andre Radulescu, who's a senior staff engineer at Qualcomm. We'll be talking about how FAPI, MAC-PHY interface, can be used for both small cells and macro cells. Andre.
Thank you. Can you hear me now?
Yep.
Thank you. So we do not have web visibility. I'm going to have to ask you to change the slides, please.
Okay, slide 1.
So if you can now be on slide 12.
Yep.
Thank you. So yeah, I'm Andre Radulescu. I'm, as Julius mentioned, senior staff engineer at Qualcomm, and Qualcomm holds rapporteurship for 2 of the FAPI specs, and I will be partly covering those specs today from a very high-level technical perspective, as well as discussing the applicability of FAPI to both small cells and macro cells. Next slide, please. That says 5G FAPI ecosystems and use cases. So yep. As Julius mentioned, FAPI is meant to encourage a vibrant ecosystem, and it follows on the footsteps of a successful 4G FAPI interface that enabled small cells using this interface that lowered the barrier to competition and innovation, allowed various companies to introduce features by focusing on the products as opposed to on the interfaces. And somewhat recent development for 5G FAPI is that it has been expanded to enable both integrated and disaggregated RAN architectures. There will be presentations by the companies discussing this. And multiple actors can benefit from this interface. Obviously, operators would be able to deploy with multiple vendors. Vendors would be able to, again, focus on the features as opposed to interfaces. And suppliers of various nodes would then have multiple choices to pick from and integrate them. Next slide, please. Slide 14 now. So here you can see the FAPI abstraction. So FAPI, taking a look from the higher layers, layer 2 and above, sees layer 1 as an abstraction, and it is composed. That abstraction is composed of configurable entities such as the baseband and the front-end unit. And once configured, then the layer 1 is driven on a slot-by-slot operation. And the operation is meant to be stateless from the point of view of over-the-air transmission and reception. And the interface itself is distilled to its most essential parameters in order to keep it as simple as possible. That interface consists of a few specifications. So one of them is the MAC-PHY specification. Here is illustrated in the red dotted highlight on the right-hand side of the picture, and is described in SCF 222, the small cell forum spec. It sees the PHY abstraction basically as a baseband, and that abstraction allows FAPI to evolve fairly straightforwardly with 3GPP releases. So it was initiated for 5G FAPI in release 15. Now TGPP is at release 16, and FAPI is advanced to release 16 in the process of doing so. The FAPI interface, as you can see in the overall cellular architecture, lies inside the DU, which itself is a node of, basically it's an entity within a G-node B. And then G-node B obviously adopts the mobile core and via the various standardized interfaces into GPP. Next slide, please. Slide 15. So here you can see the second interface that I meant to cover today, and that's the higher layer to the front-end unit interface. The front-end unit consists of the digital front-end, DFE, and of the RF component. And the RF component can be a millimeter wave component or a sub-6 component. The abstraction allows both kind of deployments, and it's agnostic to the GPP release. So even if the GPP release is advanced, this abstraction is much more likely to hold and not require a lot of tinkering. And this abstraction is captured in SEF223. It's a control plane only abstraction where MAC drives the front-end unit. Next slide, please. So on this slide, you can see the 5G FAPI architectures that are being enabled by this interface. So the original goal of FAPI was to enable distributed small cell, to have the higher layer vendors being able to interact easily with chipset vendors and ASIC vendors. So you can see that on the green bar on the top side of the picture. Then TGPP also allows a split-tree interface. From the point of view of a split-tree interface, FAPI belongs to the distributed unit, the DU, and it's an interface inside the DU box. From the point of view of the 7.2-2 interface that splits the upper and lower PHY, the FAPI lies inside the ODU unit. So split 7.2 is mostly being standardized by the ORAN group, and FAPI plays a role in that group as the MAC-PHY interface, or can play a role in that as a MAC-PHY interface. And last but not least, the small cell forum develops split 6, which will be further discussed in other presentations in this webinar. And their FAPI is transported over a network interface called NFAPI, and connects the DU unit, the S-DU unit, as you contain the MAC and above, to the S-RU, the small cell radio unit. And again, it connects MAC to PHY. So all these interfaces are being facilitated by a FAPI interface, making it easier for vendors to interact. So next slide, please. So on this slide, the 5G FAPI, beyond small cells, we will say that FAPI is not just a small cell interface, even though it's being developed by the group called Small Cell Forum. So on the Small Cell Forum side, right now FAPI is specified for TGPP release 15 support, and among others, it supports digital beamforming and precoding. It from the small cell's perspective, it focuses on MIMO via CSI feedback and via low rate channel reciprocity. It is an interface that is not just theoretical; it is verified. It is supported by companies that actually implement MAC-PHY interface and MAC RF interface. So it is not just a small cell forum interface, but it's part of active implementers. Currently, the FAPI interface is being advanced. So it's advanced for multiple reasons. One reason is to introduce macro cell support. So, for instance, we would like to introduce a massive MIMO with full support for channel reciprocity, for instance, in case of TDD, and remove various restrictions that exist today in the spec, and as well as advance the release to release 16. And support of the Radius 16 features. FAPI, as I mentioned earlier, also plays a role in ORAN. It is essentially the layer 2, layer 1 interface in the software architecture and shows up in the white box reference designs in that group. It is also an interface that's considered in the case of embedded inline acceleration. There are two kinds of acceleration ORAN. One is the inline, the other one is look-aside acceleration. So for the inline acceleration, FAPI is also considered as a good interface to handle that acceleration for the hardware designs. So as I mentioned, FAPI is not just for small cells, it's also for macro cells, and it's being developed as such. So that completes the presentation from Qualcomm. Thank you.
Thank you very much, Andre. If anyone has any questions for Andre, please put them in the chat or the question box, and we'll endeavour to answer them at the end. So we've heard about FAPI, and our next speaker, Ganesh Shadabarang from Radisys, will be who's also the rapporteur for the option 6 specification. We'll be talking about how Radisys views this specification and what you can be doing with it. So Ganesh, you there? I think you're muted, Ganesh. Oh, we had Ganesh a minute ago. Here he is.
Yeah. Sorry, I had problem unmuting myself. Sorry. Okay. Thank you, Julius, and thank you, Andre. I hope I have the control on the slides. So.
Yep, should do.
Yeah. My name is Ganesh Shadabarang from Radisys. A quick note about Radisys: we have been participating, contributing various industry forums about open RAN solutions, be it small cell forum. We've been co-working, leading with the other companies here on the NFAPI, 5G NFAPI development, and we've been active in the ORAN space as well, ORAN and XFAN, the predecessor to ORAN, and we've been contributing to specifications, open source development, and multiple industry forum activities like the Telecom Infrastructure Project, CBRS Alliance, and ONF, etc. So we provide a software solution, that's our focus, and we've been primarily building software solutions based on open interfaces. And in a few slides later, we will talk about how this is tying in together with the open interfaces of small cell forum. So I'll quickly go into the next slide. So NFAPI, we just talked about, there was a quick bit of introduction about what is NFAPI. NFAPI really is the network FAPI option, and also called option 6 split. So the 4G NFAPI and 5G NFAPI are a lot similar. We'll talk about it in detail. So the NFAPI interface is essentially the interface to enable this FAPI interfaces over the non-ideal front haul, where you can have not a very demanding kind of front haul. This interface helps system vendors, basically hardware vendors, software vendors, all of them to work on a common set of interfaces to create a disaggregated RAN architecture solution. And that is easy to virtualize on the DU side, and how this can interoperate with each other, different vendors, and so on. And it also offers the benefits of centralization. Okay, how exactly it does this? We'll see it in the next slide. So what we call as the SDU, the S prefix here is the small cell forum way of denoting what this DU contains. In this split architecture, the DU contains all the RLC and MAC, and the RU contains the PHY layer and the radio functions. And the FAPI interfaces are transported over a network wrapper, and that's what we call as NFAPI. So basically, this is a transport wrapper around the PHY API, which is defined in the base FAPI specification. And this interface now allows us to physically locate the DU and RU entities in different locations, not necessarily co-located, and how we cater to the interfaces and the control and signaling path is discussed. I'll go to the next slide. So if you really look at it, the RLC and MAC layer in the SDU, these interfaces, these layers interact with the PHY layer. There are P5 and P7 interfaces defined in FAPI, and these interfaces are the P5 interface controls the signaling messages, and the P7 carries the data. And over a network layer, we make sure that the signaling messages are transported reliably, so the P5 messages are carried over a CTP interface, and the P7 messages are carried over a UDP interface just to make the data transfer efficient. So all these basic principles are already present in the 4G NFAPI specification. So we kept the NFAPI framework intact. When we evolved this NFAPI framework for 5G, what we focused on is to make sure that the NFAPI framework for 5G, when it evolved, it is very lean and efficient to make sure that any redundancy or duplication that existed in the specification between FAPI and NFAPI, we did a lot of streamlining of the specification to make sure that these two specifications are very tightly coupled to each other, and the transport layer is lean enough to carry the right amount of overhead while transporting these messages. If you go through the specifications, you will understand the kind of optimizations we have brought in from 4G and FAPI to 5G and FAPI. We have a YouTube video tutorial as well, which gives a good overview of all these things. And when it comes to the timing aspects, the timing synchronization between the DU and RU is also maintained through a timing sync mechanism, which is defined in the NFAPI specification. Even though these units may not be co-located, they do achieve the timing sync, which is essential for the proper sync and data transfer, signaling message transfer between the entities. So that is taken care in the specification. Okay. So when we talk about how this solution is realized in the actual products, there are specific players in the market, the industry leading SoC providers who provide the base PHY capability and radio capability on a system on a chip or a platform, small cell platform. These hardware, you can think of them as COTS, commercial off-the-shelf platform. They all comply with the FAPI or NFAPI as per the architecture or design of the particular platform. And the L2, L3 stacks, whoever is the vendor implementing those 3GPP compliant L2, L3 functionality, can just integrate the software piece with the PHY plus radio, using the FAPI or NFAPI interface, handling all these interfaces, P5, P7, and P19. And the architectural variants could be either all-in-one or the disaggregated SDU, S-RU kind of solution. And the FAPI interface or the NFAPI interface comes very handy in integrating the software seamlessly on multiple SoC, and the same thing for the SoC providers too. Their product gets integrated with various software solutions. So this enables a very vibrant ecosystem of multiple SoC vendors, software vendors, and the system integrators who integrate the solution for deploying in either in an operator network or in a private network. All of this is ensured, the interoperability is ensured. We will talk about the interoperability and testing in a later slide, but this is the real power of the FAPI and NFAPI specification. What is otherwise a difficult or a laborious integration exercise becomes a more or less seamless exercise with the FAPI interfaces being honored. And this is what we have seen from Radisys' point of view, allows us to build quick the small cell solutions quickly, either whenever we talk about either FR1 spectrum or FR2 spectrum. We have done this in our experience this was our experience in 4G, and this has been our experience in 5G as well, in integrating multiple SoCs and software solution. We play the role of software developer and system integrator. When we take it to the deployment, we see that done very easily, and that's the maximum efficiency which we achieve through this NFAPI or FAPI interface in action. In the next slide, we're talking about how ORAN references the 5G FAPI spec or the MAC to 5 layer interface. So this is this picture which we've taken from ORAN's software reference design specification, where this FAPI interface is shown. If you look at it, the MAC and Hi-Fi layers are separated, or they interface through the FAPI interface. And this allows the DU vendors, the DU products to be realized with multiple PHY or L2, L3 options. And this provides the standardized interface between MAC and Hi-Fi. And we have seen this come very handy again from a Radisys point of view when we build solutions in DU. We have done this with multiple PHY options from our point of view, L2, L3 software stack solution, being integrated with multiple PHY options and underlying platform and so on. And this has come very handy and enabling the integration process to be much faster, quicker, and very less error prone. And it's easier to identify the issues here. And the most recent example I can quote here is our involvement, Radisys' involvement in developing the DU L2 layers, RLC MAC, and rest of the code. Where we used reference. This is in the ORAN open source community. I've given the link here. And our team was able to integrate with a FAPI compliant PHY. And this integration went through very smoothly in the open source community, 2 different teams implementing the L2 plus portion and the layer 1 upper PHY portion. So this is a real world example of someone implementing 5G FAPI, and there are commercial implementations as well, which the companies can talk about. But this open source implementation is there for everyone to follow. And we see that this is how it is going to, the FAPI is going to enable multiple deployment use cases, both in FR1 and FR2, and different MIMO combinations like Andre talked about. So with this kind of approach, both in the DU kind of architecture and the classic small cell architecture, we see the FAPI and NFAPI can enable different sorts of deployment use cases, and how do they interoperate and get tested, we will talk about in the next slide. And with this, I would like to close off and hand over to the next speaker. Thank you.
Thank you very much, Ganesh. So thanks for that illustration of different applications of NFAPI and how Radisys has experienced using it in practice. So next we have Vicky Messer, Director of Product Management from Picocom, who will be talking about the test support which we're adding into option 6 NFAPI for S-RU pre-configuration, something testing, conformance testing. Vicky.
Hello everyone. So as Julius has said, I'm from Picocom, and I'm going to talk about NFAPI test support, which is a current work item that we're doing with the team in the forum. So Picocom, for those who haven't come across us, we're a semiconductor company that designs Open RAN standard compliant baseband SoCs and software, specifically for 5G small cell infrastructure. And we have been active within Small Cell Forum for the last year or so, and have contributed and co-led the 5G FAPI specification releases. And also I co-led a small cell architecture and product definition paper that we released in the summer. And currently we're supporting current FAPI and NFAPI specification updates and new work items that are coming on board. And as well as co-leading the NFAPI test support work item along with Keysight. Oops, sorry. In the trends in the small cell products and architecture paper shows for disaggregated networks, there's quite an interest in option 6, particularly for indoor, enterprise and private networks. And then there seems to be a greater interest for option 2 for outdoor small cells. In either cases, the operators and system integrators will need to be able to integrate those disaggregated small cell networks made up of central units, distributed units and radio units from the different vendors. And they overall will need to be integrated to be 3GPP compliant to TS141. However, as these units are developed by different vendors, they will need to be tested individually as well, both from a functional and protocol point of view, also to have confidence that they will meet compliance performance when put in the system. But also moving more into the production phase, you'll need to be able to test the hardware and run calibration. And the O-RAN Alliance members have invested a lot of effort in this and have developed and published a front haul test specification for that purpose. But what about split option 6? So looking at the split option 6 architecture in a little bit more detail, this example is for sub-6. You've got 3 main elements. You've got the PHY SoC, which has got the upper and the lower PHY in it, and it's got an interface into the transceiver, RFIC, and then there's a separate RF front-end module or section, which has got band-specific filters and PAs, etc. And then the PHY talks over the FAPI interface for an S-RU over the FAPI interface, as explained already by the previous speakers, connecting to the MAC and RLC layers. But how would the S-RU be tested in isolation when the 3GP compliance specs assume that you're testing as a complete system? So operators and vendors need to be confident that they'll be 3GP compliant when testing as a complete system. And also option 6 has some advantages. The S-RU contains a complete PHY and the RF system. And the 3GPP compliance specification is primarily testing the PHY and RF performance. So we've got the team at Small Cell Forum have been discussing this in quite a bit of detail over the last few months. And we've been able to make some conclusions about the way to go forward. And we believe that if the FAPI messages can be extended to support the TS38.141 test modes, the S-RU can be tested in isolation. And there's no specific front haul feature or DU emulator requirements that are needed, and standard 5G test equipment from the ecosystem of test vendors can be used. And the FAPI interface can be used also to provide a standardized open RAN test interface. So looking at it a little bit more detail at this generic setup, starting on the right, you've got just a PC running a test application, so that might be test vendors or an in-house. And then you've got the device under test is the S-RU, and you've got the FAPI messages. The FAPI is connected to the S-RU, sending these extended FAPI messages. So you've got just controlling the test model, the fixed reference channels on the uplink, retrieving block error rate measurements, and also controlling the RF channels, etc. And then according to whether you're sub-6 or millimeter wave, you would have a conducted or an over-the-air interface to the test equipment. And I've shown it here generically, so it could be the sort of more traditional vector signal analyzer and signal generator, and a separate channel emulator, which is needed for some of the receiver measurements. But you could also, in certain test cases, such as channel 8, chapter 8, you can use a UE emulator which integrates those functions. So the actual test plan will be dependent on the S-RU specification, and we've done some quite detailed analysis of how the more complex chapter 8 receive tests could be done by adding some test functionality in order to be able to send back ACNAC messages and retrieve the block error rate measurements. So we're sort of aligned on that now. And also a subset of this test setup and test plan could be used for production, calibration, and hardware verification. So finally, what is Small Cell Forum doing to help with S-RU and SDU test support? So currently we've been doing some detailed test alignment, particularly on the conformance side. And this interface can also be used for full conformance testing. So being able to set up test models, etc., would still be useful over the FAPI interface. We mentioned it's very important to be able to do the S-RU pre-compliance testing, but there's also a potential. We will also sort of aligning on the internet protocol testing and also testing the SDU element as well. And finally, the manufacturing test side. So we're targeting to submit these new messages in the next FAPI release, which we're targeting either Q2 or Q1 next year. And we're also starting to draft an accompanying white paper, which gives more guidance about the relevant test specifications, example test solutions, how you would use the test messages, etc. And this currently a full test specification is out of scope for this phase because we see it's well aligned with the 3GPP specification, but it may be that the industry would like further development of that. Thank you very much. I will pass you on to the next presenter.
Great, thank you, Vicky. So now we're showing how the testing for SRUs can be quite simple, leveraging a lot of the work that's already been done by 3GPP, which is already quite well aligned to testing the physical layer. Great, and again, keep the questions coming in. I've seen a few coming in on the chat here, and we are farming them out, and we'll endeavour to answer them at the end. So our next speaker, and to wrap it all together, is Ravi Sinha from Reliance Jio, who'll be talking about how Open RAN can be built with option 6 FAPI and how it might set to disrupt business. Ravi.
Thank you, Julius. Hi, everyone. Greetings from Reliance Jio. By the way, just a small intro, I'm Ravi Sinha from Reliance Jio, working for product development and technology. Also kind of co-chair with Prabhakar and 5G and Tech. This is a kind of very important topic we are covering because technology side, I'm sure that Qualcomm as well as Picocom, Radisys, they have covered it very well. But it is equally important to figure it out where the rubber meets the road and find it out that how the adoption of all the great technology and specifications, SCF or ORAN and all the big organizations are contributing, how exactly it can be adopted. So this particular kind of presentation will be very much aligned to the solution, blueprints, businesses, and more. So Julius, can you please go to the next slide, please? So as we know that when any specification or any work starts, we would like to understand ultimately how the different pillars of the environments or ecosystems aligned for that particular work. And as we can see that industry-wise, overall, when we transition from 4G to 5G, a lot of things were virtualized. Hardware was decoupled with the software. A lot of other changes happened from the packaging of radio to the core. But ultimately, if we see it broadly, we can see that near about 80% of the business in 5G will be in future will be very much aligned to the services than connectivity. So it is important that every service their specific requirement is being driven by a cognitive auto-driven connectivity. In that way, we can give a great user experience overall for the end user based on the kind of services you are launching. So industry-wise, as the earlier presenters have also said, that Mac and PHY integration is given, it is a must. And for that, FAPI is playing a great role over there. Starting from 4G now, it is 5G. Specifications were out this year, and industry is taking it wholeheartedly. And I can see that this is further extended to your NFAPI side, where we are taking it to a S-RU and SDU kind of split, where your S-RU is at the tower side, and SDU can be local or it can be remote. So of course, NFAPI 5G kind of NFAPI, which is now kind of considered as option 6 or open 6, is going to play a kind of big role over there. In terms of economy, as you know that the number of small cells will be many folds more than your macro. So ultimately, there is a huge sum of you can say budget is engaged. So if we have an optimal solution, definitely we need to kind of consider something which is small, portable, and flexible, which can be easily customized for the services. So economy equally plays a great role. And in terms of solutions, we have recently released 15 based 5G and FAPI compliance specifications, and we are in process to go for the second phase of it. So that is also good, and there is a reference spec available for the industry so that the industry can go forward. Overall impact is equally good. We are seeing and hearing a lot of positives about Open 6. So very happy about the overall kind of adoption within, and I'm sure that in future we can see more. Julius, can you please go to the next one? So these are the 4 different splits. As we can see at the left corner and right corners, option 2 and option 8 evolve in the industry because of the ease of building solutions around it. But ultimately, the industry has found more values around the lower layer splits, which is your option 6 and option 5. I'll not go to the details of it, but would like to quote one thing, that ORAN and SCF, we all work very closely with each other. We partner, we make sure that we complement each other to build an ecosystem which is open for all and flexible for the industry to build a solution out of it. Next slide, please. So here are the kind of the basic 3 different, you can say, major drivers. One side is your carriers, OEM, SOC vendors, and x86 vendors who are building the solutions or ecosystem to enable split 6 or the other kind of split options. But then along with that, organizations like ORAN, SCF, TIP, they all are kind of working together, complementing each other to promote the solutions coming out of it in terms of distributed RAN or open RAN. Along with that, I'm also seeing optical fiber is equally important overall because of the front haul, back haul, or front haul, back haul requirements you may have, or mid haul requirement you may have. So optical players are equally playing a great role overall to bring a very disruptive as well as kind of a productive solutioning around it, and they also kind of come up with a lot of gateway options. So which is equally important because those gateways can converge as well as it can give you a different dimensions in terms of your need for front haul, mid haul, or the other kind of backhaul kind of needs. Basically, carriers and OEMs and SOCs, a lot of it is already kind of discussed, but just kind of short. Telco industry has moved forward with the 3GPP release 15 phase 1, And now it is working on 16 phase 2, and we are seeing a lot of activities happening there. Our FAPI specs are already kind of released, and it is getting kind of integrated with DU and RU across with the PNF and BNF kind of offerings. The good part with the SOC portion or the SOC offering is that in the SOC, they always kind of release the SDK, and it is a kind of tightly integrated PHY, which is also serving all your acceleration needs and any kind of coding needs and all those things sitting on a single chip, whether it is a sub-6 of 100 megahertz, or you can say 400 megahertz and to 800 megahertz on millimeter wave. So putting it on a chip is a easier proposition, but definitely you can see also a lot of value when you go for FPGAs and x86 platforms, because they give you a flexibility for macro and micro, where kind of you can have a kind of lot of benefits over there too. So these are the kind of major kind of enablers or drivers to go forward for Open 6 or Split 6, as well as your kind of Split 7. So next slide, please. So here are the major advantages. Some of it I have already kind of covered in the previous slides, but very cost-effective solutions. So in terms of cost, as you know that the 4G transition from 3G, and the cost was important so that we can push it to indoors, houses, femtos, enterprise, combos where 4G and then Wi-Fi can go together. And for those things, I think FAPI has played a great role, and I can see that it is further extended to 5G and FAPI. It's a kind of simple RDU architecture where your radio and distribution units are very simpler. Even PHY is well proven because they are kind of kind of integrated together, not a separate pieces. Mature and unified PHY fully ported to well-proven silicon frameworks, whether it is Qualcomm or Intel or Marvell. So I'm seeing kind of in those areas, kind of inconsistency or performance-wise, there is not much risk. Simple design and no FPGA or acceleration needed, and especially in Split 6. Relatively lower front haul payloads. If you can see the payloads of this one compared to some of the other options, it is relatively low. Some of the kind of applications will be coming in future, URLC or some of the others like those. I can see that Split 6 is a good option along with some of the others. And along with that, since it is open source, the royalty is not a kind of big challenge over here. So in that way, I can see that Split 6 will get a better traction in coming years. Next slide, please. So this is the kind of important piece to understand that whether we go for option 6 or option 7, how exactly my services are getting aligned to the different kind of splits we have. So as you can see that if we put FAPI to an enterprise domain or something like airports or big public areas or private areas, definitely I can see smart edge or applications or financial, public sector, healthcare, smart cities, AR/VR. AR/VR is specifically like you can see that if you have a small cell clusters and there are some of the locals, definitely you can see a lot of advantage over there. Next slide, please. So I think this slide kind of talks about overall picture of when the solution is built and when the FAPI or FAPI is all from the RU to a DU or SRU to SDU. Ultimately, the overall integration for the services will also go through the smart radio controllers, and those things can be a piece coming from a kind of RIC, whether it's a near real time or non-real time. In all those cases, all the different modules of SON or some of the other kind of AI converged engines that can be even over here or distributed fashion can go, and some of the special XApps or RFs can be easily written to kind of to align specifics of NFAPI or the kind of smartness you're looking for from the radio side, integrating with the core side or network elements. Next slide, please. So the business case promoting these, of course, kind of a piece of it we talked, carriers, OEM, silicon vendors, system integrators, non-public 5G NR operators. Non-public 5G NR operators, I can see that this is going to be growing really fast, and anything based on unlicensed spectrums, especially in US, things are promoted very well. So I can see a lot of possibilities and a lot of business there. In terms of contributions, I'm sure that Small Cell Forum and ORAN and others are doing our level best to bring the openness to radios and integrate it with services, because that is very important. And anything we are doing on our interfaces to align services is a prime, is the main focus. Silicon vendors and OEMs, we have already talked about it, and OEMs also, they have started adopting option 6 along with option 7, so which is a good thing, and we can see the success at the end of the day, so that is great. System integrators, as you can see that Radisys is heavily engaged, and I can see that they will take the concepts. I'm hopeful that they can take the concepts to the solutions. And carriers like us and all over worldwide, we are positively looking forward to figure out the different use cases where we can fit in option 6, option 7, and some of the other combinations over there. Next slide, please. So in summary, I think we have already talked about it. So most of the things, but one piece I would like to mention over here is ultimately in Asia, I think combination of 4G or 5G with Wi-Fi, whether it's Wi-Fi 5, 802.11ac or 6, which is AX. I think Wi-Fi 6 approach goes very well, where like you can do a lot of conversions together at S-RU or RU. And you can combine a Wi-Fi and 5G NR to your DU or CU level, and you can do a lot of disruption, whether it is data aggregation or something like LAA or LWIP or LWA kind of concepts. You can take it forward with this architecture, and I'm positive that that will be adopted aggressively in that regard. So this is this is the end of my slides. Thanks a lot, everyone, for listening to us.
Thank you, Ravi. Thank you very much. To hear your view on how it's going to come together. So now we have a brief opportunity for a few questions. Now I've been looking at the chat coming in, and I've put them into an email, and perhaps we can try and run through some of these now with the team. If there's more coming in, then please do carry on. So let's make that a bit bigger. So one of the questions we always get, which is basically option 6 versus option 7, what's the difference? Now we've seen this question here on the transport bandwidth being slightly higher in option 7.2, but with compression it sort of brings it down to be 25% different. So, but you can't do that on uplink. So the question is what are the other pros and cons of option 6? So I think that's always going to be out there, and in a way I think it's for the deployers and the implementers to make those decisions. I don't know if anyone on our panel would like to propose an answer, perhaps Ganesh or Ravi. Do you have a view on that?
Sure, I think Ganesh, you'd like to go first? Okay.
Yeah, Julie. So thanks, Ravi. So this kind of comparison based on the when we compare against the category A or category B, the exact calculation of the delta, and the question being compression, right? And as we evolve the NFAPI specification, there are options which we can consider as well in FAPI to improve the specification. We definitely are looking at how to efficiently do the data transfer, the P7 data transfer as well. So over a period of time, we believe the delta would be, I mean, in many of these cases, maybe in the range, and it's purely based on the deployment options of what is available as fronthaul. That would be my view.
So, so as Ganesh rightly said, that it all depends upon the use case and the location of DU to RU ultimately, and then the kind of compression you're using. If it is just BFK, then definitely block floating point is a little bit limited. But if you go for modulation, definitely the delta is not that much. But then again, if you're putting it remote or local, it has some changes, and based on that, you have to kind of pick it which one to go with. I see both sides are doable. Both sides are equally flexible in that.
I did see a SensorFeely analysis recently, which ORAN should I go for, and it looked at low-cost transport and high-cost transport operators and suggested that operators that pay for transport or pay a lot for transport or are sensitive to transport costs would save 30% TCO by going to F1 split 2 compared to F1 split 7 to 7.2. So maybe that's an upper bound on the kind of saving that you might experience. So have a look at that. Let's move on. So next question, is the FAPI interface an open interface compliant to ORAN? Well, ORAN is not the only open thing in the world, I guess. FAPI is definitely open. The specification has been published, and they go back to, I think 2012 was our first 3G FAPI specification. So they're widely out there and adopted and used by chipset vendors today. Anyone else want to add to that?
I'll just add that the FAPI interface that was also mentioned in the slides by Ganesh, I think, is adopted within the ORAN Alliance as well, as an interface between the PHY and the MAC layers within the ODU.
Yeah, there was a question on that somewhere else, wasn't there? That's right. But so FAPI is, like I say, is adopted as a part of the reference design, isn't it? How many companies have implemented 5G FAPI? Well, I think there's at least 3 here. Anyone else got other comments on that?
Yeah, so I can say most of the SoC vendors are adopting FAPI for gaming companies from the experience of Radisys working with the broader ecosystem of players. You can see that what we saw in 4G is also being a trend in 5G, all these vendors exposing FAPI-based APIs.
Oh,
I think deployment of openness is anyway new. If you think about the scale of it, is really low because there are kind of challenges with the superior supply chain, and I'm sure that is getting better. FCC has also kind of talked about it, and they are also prioritizing those areas. So I'm sure that with time, 2021 is the year where you can see a lot of scaling going around. So I can see that a lot of adoptions worldwide from most of the tier 1 vendors, as well as tier 1 carriers, as well as the OEMs and silicon vendors. So forth.
Right. So
and I guess speaking for Qualcomm also, we see FAPI as a very important interface. It's effectively the only open standardized interface out there for Mac to interact with layer 1. So it's pretty important that it's available so that industry can adopt it, and for Qualcomm also we see it as a very important interface.
Great, thanks everyone. So how relevant is FAPI and usable in ORAN? Well, this has been talked about, but I think Ganesh mentioned it's part of the and Vicky mentioned FAPI's here in the reference design. You get a hi-fi shim, I guess. Ganesh?
Yeah, I'm just trying to read the question. So
it's the use of FAPI within ORAN solutions.
Yeah, basically, I think practically this is the interface between the MAC layer and the Hi-Fi. Basically, in ORAN, I'm part of the ORAN stack reference design group, and this is a consensus among different groups in ORAN. I'm co-chairing this group, so we have discussed with multiple groups, and the consensus is that we will adopt the FAPI interface as the standardized interface between the MAC and the Hi-Fi in ORAN's DU architecture.
Yeah, I noticed Ravi was mentioning transport vendors who can have these Hi-Fi shims in sort of converting option 7 to option 6 as part of a transport network. There's another way of using it. So what's the full form of FAPI? I think that just means, what does it mean? So I guess it's well, it was originally FEPSO API back in when it was born, but now I think it's functional API. It's just an API really for small cells. But as Andre pointed out, it's for macro cells too now. What are the advantages?
And also, if I may add for the relevance to ORAN, FAPI is also mentioned as an interface for hardware acceleration, inline hardware acceleration. So this is in addition to the use case that Ganesh was talking about as the MAC-PHY interface.
Yes, right, hardware acceleration in the ODU. Again, the question of advantages over split 6 over 7.x. Anyone want to cast a view on that?
I think there is no comparison. I think these are two kind of very promising options, and they have their own space and they're good in their own areas. Of course, kind of overall adaptation, ORAN has done much more work along with interfaces. They have gone forward to bring a kind of complete framework, starting from AI engines to the applications to the smartness on the top. So of course, SEF would like to tell you the fact, I would like to see the everything what ORAN has done, the smartness on the top can be leveraged overall, so that the coexistence of SDU and then ODU, they all go under the same umbrella, and then the solution is built for different kinds of services. So I see a kind of a great future overall for SEF and ORAN together.
Ganesh, do you have a view on the sort of alignment of the two sort of standards there?
We are still talking about the 6 and 7.x comparison, right? So yeah. So I think these will coexist based on the different deployment needs. I think rather than comparing these, I think we need to see the suitability, like you mentioned earlier, about the aspects of fronthaul, cost involved, and what the deployment use case needs, right? So it's going to be based on that.
Okay. Now the next question. Under option 6, can you have PHY and the radio being connected via eCPRI? Right. Anyone want to cast a view on the separation of PHY and the radio? Sounds like a P19 type question.
So if I may ask, so basically this is a question, I believe, whether split 6 and split 7 can be had in the same architecture. So I guess in theory that's possible, but in reality I'm not aware of any commercial deployment that deploys both. So usually deploy one or the other.
Okay.
So I think the question says that can you have option 6, PHY and radio being connected being eCPRI? So eCPRI is, again, it is not CPRI, it is eCPRI, right? So it is split 7. So will it be really viable when you have your option 8 going on CPRI, then like going to PHY, then eCPRI, and everything is local? So this whole combo will be very complicated, and what is the gain of it? I think those things needs to be evaluated.
Okay. I hope that answers that question. The next one, this is referring to one of your slides, Ganesh.
Yeah, it's more about FAPI. I think this is the FAPI interface shown in the block diagram, which is a diagram taken from the ORAN WGA working group specification. So we showed FAPI interface, not the NFAPI interface. We already discussed this, that the MAC PHY interface in this case, the MAC and upper PHY interface in this case will be FAPI.
Okay, thank you. Someone's asking about slides. Yes, I think we're sending the slides out tomorrow, and the recording of this webinar will be also available and sent out to all the registries or whatever. Next question, we're nearly there. Appreciate people hanging on to answer if you were to listen to these. There's only a couple more, so we'll get through them. Can an S-RU supporting FAPI be entirely in an ORU? I guess
so.
No.
Yeah, Julius, I copied the response below. It should say ORU in there. Yeah. So yes. It's just saying that there's a difference between option 7.2 and option 6, which I think we've talked about earlier.
Yeah, I think an S-RU actually has more functions than an ORU, so it
Exactly.
couldn't fit
yeah.
in, could it?
Yeah.
Yeah, it's not the interface, it's the PHY functionality which is fully defined within the S-RU.
Yeah.
Okay. Can split 6N FAPI become a part of ORAN Alliance, given if white box ORUs become reality? What happens to both 7.x and NFAPI can coexist? So we had discussed this a bit earlier, hadn't we?
Yeah, this split 6 becoming part of ORAN, I think it's probably not appropriate to comment on that here in this webinar, but such discussions will be happening within ORAN 2, and basically FAPI at least is being referenced in ORAN specification, but I think we'll have to see how the standards align in ORAN specification, including a reference to the NFAPI later. So that part is in future maybe we might see. So it's not probably we cannot comment for sure in this forum.
Sure, I guess it's fair to say all of the members working on the NFAPI option 6 and FAPI are also members of ORAN, so that should help to drive, alignment and coherence and coexistence of those. And finally, different operators using different vendor equipment in ecosystem. How can small cell be used considering complex ORAN architecture?
Can I take that question, Julius?
Sure.
Yeah, so I think we are seeing 5G deployments being multi-layer densification, and then can have all of these things coexisting, deployed, overlaid on each other, right? So the macro base stations, which is a monolithic G node, be transmitting in one particular band, and you might have a CDU split architecture to cover certain areas. You might have small cells on top of that to provide either indoor coverage or outdoor coverage. It could be an outdoor small cell or an indoor small cell, either in FR1 or FR2 spectrum. So when it comes to a small cell kind of solution, those interfaces, the open interfaces which we have defined in small cell forum will come in handy. Those implementations, basically the products and the respective implementation with that split, will be appropriate to cater to those use cases and deployments and others. So it's going to be a harmonious coexistence of all these options, to put it this way, the way the operators are looking at. Multiple operators are considering both the ORAN based solution or deployment plus the small cell based deployment.
Okay. Anyone else? If not, well, I think that's all of the questions that I've received. So if you do have any more, you can send them in and we'll get back to you on email. But otherwise, I'd just like to wrap this up by thanking all of our presenters today. They did a great job of showing the applications of the FAPI and as well as also the open option 6 interfaces that we define. And if you want more information, those links have been provided to the download pages and videos that we've provided on these specs. Otherwise, thank you very much and have a nice week.
Thanks a lot, everyone. Take care. Bye-bye.
Thank you, everyone.
Thanks a lot.
Thank you. Bye.